Jasvi.
I'm Bo.
I'm Brian. And I'm Naveen. And we are Collaborative Classrooms Incorporated.
Here at Collaborative Classrooms Incorporated, our mission is to facilitate student and instructor collaboration for an improved classroom learning environment.
Computing technology has the potential to radically change the higher education classroom by increasing access to information and facilitating the sharing of content in real time between students and the instructor. Our specific goals for the project are to increase student engagement in the class, to provide feedback to the instructor on student understanding, and to integrate student materials into classroom discussions.
We originally started out with an idea for an automatic whiteboard cleaner/scanner. But through market research, through interviews with students and several professors, we determined that the current needs of the classroom weren't adequately satisfied by this idea. Through a Pew Matrix, we determined that there were better alternatives to satisfy the classroom needs, the best of which is our current design.
Now this brings us to the final prototype of our classroom. The final prototype of our classroom revolves around four main components: the whiteboard system, the desk chair tablet system, the app interface, and the live experiments. We designed our final classroom to hold 24 students. The smart whiteboard system is a dual system between the teacher's desk and the student phones. The teacher's desk will be Bluetooth connected to the whiteboard so that all written notes are projected on it. The teachers will also have the ability to livecast their phone or laptop via the internet, which facilitates long-distance teaching. Each of the 24 classroom tables will be around 2 meters wide. They come with inbuilt plug points to charge the desk tablets or personal laptops. The tablet store brackets are located in the side of the table, which are locked when the class is not in session. The tablets also have a swipe feature, which lets the student swipe his or her university ID to unlock the tablet to the class home screen. This also allows the student to give his or her attendance to the professor. Now coming to the app interface. The app interface on the student's tablet is basically the professor's presentation covering most of the screen, along with a sidebar that contains a live feed of questions on the top and a text box on the bottom to allow the students to type out their questions. Other features of the app include options to allow the students to request the professor to repeat a slide, talk slower, talk faster, talk louder, or to spend more time on a slide. The app also allows the students to take private notes during class time and save them to their home drive. The app has a livecast feature which lets the student of the professor's choice to answer problems or questions. The app interface would be a bit different for the professor though. The professor will have all the students' names on the sidebar, which lets him or her give permission to the student to cast his or her answers to the class. The professor also receives anonymous requests to talk louder, faster, etc., and the professor will make a decision based on the consensus. The professor will also be able to see the live question feed and decide to answer the important or the most asked questions. Coming to the live experiments, when they go live during class time, a chat screen is available to the students in their tablet where they can ask questions and communicate with each other and their instructor all in real time.
When discussing the budget for our project, we must first look at the cost analysis our team performed. We have estimated the cost of hardware at $20,000 and between $150,000 and $2 million for the software development. This large discrepancy in the software cost is due to the uncertainty in the amount of code needed. These two figures put the cost for developing the first prototype between $170,000 and $2,020,000. Based on the estimated cost of the first prototype, we can develop a budget for this phase of development. The cost for hardware does not account for the minor amount of labor needed to assemble the prototype. If we account for this added cost, we can put our budget for hardware at $50,000. The budget for software will be based on the higher estimated cost to avoid running out of money. This cost estimation for the software takes into account labor, but we will also add a safety factor into our budget for any unforeseen problems. The total budget for the prototyping stage of our system will be $2.2 million.
we have completed quite a lot of the process, we still have a long way to go until the interface is up and running. Our project timeline is divided into 6 stages: planning for 2 to 3 weeks, design for 4 to 12 weeks, development and programming for 6 to 15 weeks, followed by testing and review for 2 to 6 weeks. We then have the interface launch for 1 to 2 weeks and the maintenance and enhancements, which is a constantly ongoing process.